waiting for you. Go. Let's do those now.
2 through 5.
Should I do 2? Sorry, 2 through 5. What did I say? 2, 1.
Yeah.
2, 5. Electric field. So electric field equals force per unit charge. So that's going to be force of 4.0 times 10 to the -2 per unit charge, which is 8 coulombs. I get 0.5 times 10 to the -2, or 0.005. Is that right?
Mm-hmm.
Did I do that right? Missing a 0?
No.
Good? Okay. So that's my force caused by that. Okay. So then the next question is, if this was actually caused by a point charge, so I've got a charge that's making this happen. So I now know, wait a second. It says, if the field above are charged by a point charge, how big would the charge need to be if they're 4 meters away? So they're 4 meters away. So at 4 meters away, I want to know what I'm getting this electric field, right? How much force is on it, though?
The
4 times 4.0 times 10 to the -2. So if that's the force, and my charge is 8 coulombs, can't I figure out what this charge over here has to be to make that force happen? So I'm going to go, force of electricity is KQQ over D squared. 9 times 10 to the 9th times the first Q, which is 4 times 10 to the -2. Nope, that's wrong. 8, right? 8. And the second charge, which I don't know, divided by distance between them, which is 4 squared. When that force is going to lead to 4 times 10 to the -2. So I can solve for Q. Yeah.
8 coulombs is like a lot.
Yes.
But that's really.
Yes. I mean, if you look at the problems, in the first couple problems, you had like -6 micro. So you had times 10 to the -6. That's enough to deliver 1, 2 Newton of force. Right? Those are micro coulombs. Coulomb of charge is a huge amount of charge. Okay, it is, you know, the fundamental. I mean, it takes times 10 to the 19 of them, of the fundamental charges, just to make 9 coulombs.
So is there a real thing that, like, what's point correspond to, like, these reference? Yeah, like
What's a way you can, like, how big is this? What's the sort of thing? I don't have a great answer to that question. When we were doing the circuit stuff, and you were measuring amperage. Remember what amperage is? So let's say I had, and by the way, you know, like that one power supply provides 8 amps, which is darn close to lethal. Okay, that is 8 coulombs every second, is what it's delivering. And that is a lot. It's enough to cook a hot dog in seconds. That's enough to. So that might be a way you could look at it. But as far as actual charges, you can field charges because of the field they emit at times 10 to the -6 pretty easily. So if you can field a charge, it's about times 10 to the -6. I would say that's roughly where that appears. That's when your hair starts to stand up. You start to be bothered by it if you get close enough to it. A full coulomb of charge is dangerous, especially if it delivers very fast, because the amperage is what kills you, not the charge. But I mean, if it discharges almost immediately. Now, to give you another scale, I mean, lightning bolts have super amounts of coulombs. So it is a larger unit than it needs to be, probably, but it's not ridiculously large. Fair enough?
Yeah.
Okay.
Nothing else.
You good?
Yeah, I was gonna ask yourself for the answer just to see if
Okay.
I was right.
Let me back up.
Okay.
I think you mean on the previous one.
16,
2, 4, 1/4, 1/4, 1/32. Nope, can't do that in my head. 4 to the -2 times 16 divided by 9, exponent 9 divided by 8, and I get 8.88 times 10 to the -12. 8.89 actually. Yeah. Cool. Make sense?
Mm-hmm.
You good. All right. Get down through 5. You got